Hi everyone, I'm Paul Tarau and I will talk about NatLog, embedding logic programming into the Python deep learning ecosystem. So the motivation is to take advantage of some deep family resemblances, and I'm using family resemblances in the sense that Wittgenstein long time ago associated to that deep connections between the way games work, while the language games work in Prolog and Python. NatLog is easy to install. Here is pip3 install NatLog. It's implemented in Python and ready to play, very few dependencies. The family resemblances are between Python generators and Prolog's backtracking. Similar representation of interesting data structures, Python's nested tuples and Prolog terms, Python's coroutines and Prolog's first-class logic engines, when available, make a very flexible interaction mechanism between the two, and then Python's reflection and Prolog's meta-interpretation allow execution to be passed from one side to the other very easily. And a few other minor similarities, list comprehensions and find all, syntax similarities, easy to write I/O, compound objects, and then you have an interactive REPL, and you have automatic memory management on the two sides, so it's easy to borrow from the side that has it if you use it as an implementation language. So some of the very quick overview of NatLog features. Prolog syntax almost, except unnecessary parentheses are gone, and other than that, very similar. Pretty self-explanatory, I guess, in this ancestor example and sibling example from the family program. Terms are represented as nested tuples, and all Python data types are directly reflected, except for a variable that has a single value slot in which you can bind and put whatever you want and then remove and backtracking. NatLog benefits from Python's memory management, and no data conversion is needed, but it's not slow nevertheless. It's an interpreter, reasonably fast with its own goal stack, more than 200k leaps under this accelerator PyPy that runs very well for up to medium-sized programs. The data exchanges between the two use a very uniform syntax. Everything that's a callable, and that's a lot of things in Python, functions, classes, instances defining a call method, they all are invoked, like in this example. This means call Python function. This is the length function. The tuple is ABC. Return it in the variable L, comes back as a dictionary. Generators, so multiple answers come back this time. This intuitive quote, back quote, and then the results coming back as a dictionary. How we reflect metaprogramming constructs. Here you can see that Python's reflection that allows you to set an attribute or get an attribute that you name as a string, well, as a symbol in NatLog, can be reflected by just calling either a procedure or a function that returns something. And with that, you can define things like method call at source level. And here's a simple example of a data structure, a stack, defined also all at source level in NatLog. So you can borrow very easily all the interesting data types, very convenient, notation for them in NatLog without too much bureaucracy in expressing the transfer from one side to the other. That's very important when you connect languages. Coroutining is a key element that we really like on the two sides. A first-class logic engine is a language processor reflected through an API that allows its computations to be controlled interactively from another logic engine. So this is very much what we do in NatLog. It's what a Prolog programmer does anyway, except that this time it's the program that does it. So the API is very simple. You can create an engine with a goal and the goal pattern to return. You can ask an answer instance, comes back as instance of this pattern. And then you can, of course, stop the engine, and then all the future answers would be no. Otherwise, it would be the answer when there is one, and no if there is no answer. The two extensions to this simple engine API, one of them is to be able to eject from an infinite loop an arbitrary term that would look from the client as a computed answer. So you decide that this is a good answer at this time, you eject it, it comes out on the other side. It's very important when you are in an infinite loop, which is convenient and short, like in a functional programming language to write, and then you would collect all those values as if they came out on backtracking. The trust engine operation handles the fact that we do not have a heap garbage collector. We accumulate on the AND stack, possibly an infinite string of calls, and then we then would have a simple operations here called trust. You discard all the past history of the computation, and you compute as if you started with the loop in this position. So with that you can generate infinite loops, infinite stream of natural language here, returning solutions as if they would happen on backtracking. Now, because we are talking about the interaction with the Python deep learning ecosystem, let's see JAX example. JAX is a very nice kind of high-level functional style interface, wrapper around the basic TensorFlow operations. What you can do on the NatLog side, you create the data. Here it's a deep XOR loop that we are building. A deep XOR, it's notoriously hard to be solved by neural networks. It's a good test for how far they can go and how quickly they can solve it. Here we use a multi-layer perceptron for that. We have also a similar interface for Torch, by the way, which is a bit more popular at this time than JAX with its nice object-oriented syntax. Logic grammars can be used as prompt generators. Prompting large language models is called prompt engineering at this time, and because it's actually a very important operation. So here we have with Prolog's DCG, with NatLog's borrowed from Prolog DCG notation. That's the DCG arrow, a little bit simpler here, and that's a sentence defined as non-terminals here and deep down step by step. The queries come out and then they are sent to the large language model interface on the Python side. So with that you can do with our little API that I just sketched before, answers to 3 types of questions. just a plain query where you want to know something. So you ask, in this case, GPT-3, what are transformers, and you get a reasonably good answer back in Atlog, where you can start understanding it, processing it, connecting it to a background knowledge base, and so on. You can also make the large language model do the splitting into subject, verb, object triples. Here the quick brown fox is the subject, the verb is jumps, and the object is lazy dog. And then you can make analogies like between car, wheel, and bird, each of them with little variations of the DC-generated prompt. Of course, this gets even more interesting when you write a grammar to a text to image generation, in this case with DALL-E, that can be accessed directly with the API at this time, or if not, well, the result could be pasted directly in a local, web-based interface to DALL-E. But here I have an API, and all you have to say is paint, text description of intended image, and the image would pop up in your browser. So relatively high level interaction, possibly usable by beginners or for teaching applications. Well, this is paint photorealistic rendering of shiny robot walking on planet Mars. And if it's with a sombrero, then it would look like this. Otherwise, it would look like that. As you see, the usual bias, even for robots, is there. That's one of the issues that large language models face. Sometimes they are not very good. Sometimes, like in this case, they are okay. And then you can also have a twist in the style. You can see them in a Chagall style in this case. Again, a variant of the grammar would give you those prompts. The conclusion is that by having those deep language resemblances, language family resemblances shared between the two, you can have a very lightweight and easy to use interface. And the next thing that this research actually extended by now to is full automation of goal-driven LLM dialogue threads with and/or recursor and refiner oracles, so multiple GPT agents interacting interestingly to actually create virtual logic engines. Take a look at the links here, and or just search for me on arXiv. That would be upcoming research. The full code is available at my GitHub site. Thank you very much.